Gold, the most expensive metal in the world, their metal, on which a huge part of the world's economy depends. When its price goes up, economies rise. When its price falls, markets shake. People invest in it, trust it, store their wealth in it, because gold is considered stable, reliable, almost untouchable. It doesn't rust. It doesn't easily react with other substances. And once you have gold, it stays gold. That's why it can endure for centuries. It has been seen as something permanent, but here's something most people don't know. Even this untouchable metal can actually disappear. Yeah, there exists a special chemical mixture, known as aqua regia, that can dissolve gold completely. Not melt it, not break it. Dissolve it into a liquid. Now just imagine this for a second. You're holding a piece of gold in your hand. Solid, heavy, valuable, and then you drop it into this solution. At first, nothing happens. A few seconds pass and you might think, okay, nothing's going on. But then slowly, something begins to change. The surface starts reacting. Bit by bit, the gold starts disappearing, until that solid piece of gold is completely gone. No solid left, just a liquid. Now here's where it gets really interesting. The gold isn't destroyed. It's still there, just hidden in a completely different form. And the most surprising part? You can actually bring it back. From liquid, back to solid gold. So in this video, we're going to understand how this happens, what kind of chemistry is behind it, and how something as stable as gold can completely transform. And trust me, this is going to change the way you... Before we go deeper into that reaction, we need to understand one basic thing. What exactly is a metal? Metals are materials that are usually strong, shiny, and good conductors of heat and electricity. They can be shaped easily. They can carry current, and most importantly, they are made up of atoms arranged in a very organized structure. Now, gold is also a metal, but it's special because unlike most metals, it doesn't react easily. That's why it doesn't rust, and it stays stable for a very long time. But here's something even more fascinating. Do you know where metals like gold actually come from? They're not just formed on Earth. Scientists believe that heavy elements like gold are created in space during extreme cosmic events, like when massive stars explode or when neutron stars collide. The energy released is so powerful that new heavy elements are formed, and gold is one of them. Now, I'm not going too deep into this part here, but if you want a complete, detailed video on how gold is actually formed in space, I've put the link in the description. You can check it out from there. Here, I just wanted to give you a basic idea, because the main focus of this video is something else. Now think about this. Something that took extreme cosmic conditions to form, something so stable, so rare. How can it be dissolved so easily in a liquid? That's where things get really interesting, because now we're stepping into the main topic, the chemistry behind the solution that can break down even gold, the solution that can dissolve gold. It's called aqua regia. The name literally means royal water, and the reason behind that name is simple, because it can dissolve the king of metals, Akari, gold. But here's something interesting most people don't know. This is not a modern discovery. Aqua regia was actually known hundreds of years ago. Early alchemists, the people who were trying to understand metals and transform them, were the first to discover this powerful mixture. One of the earliest recorded mentions comes from a medieval alchemist named Pseudo-Geber. He described a method of combining strong acids that could do something no ordinary substance could: attack gold. At that time, this was shocking, because gold was believed to be almost indestructible. So how did they figure it out? Through experiments, simple but risky experiments. They would take different acids, mix them in various proportions, and then test them on metals. Most combinations failed, nothing happened. But then one particular mixture, nitric acid and hydrochloric acid, showed something unusual. When gold was placed into it, it didn't just sit there. It started reacting, slowly dissolving. And that's how aqua regia was discovered. Now today we understand the chemistry behind it. Nitric acid acts as a strong oxidizing agent, It removes electrons from gold atoms. And hydrochloric acid provides chloride ions, which bind with those gold ions. Together, they pull gold out of its solid structure and turn it into a dissolved form inside the liquid. So what early alchemists discovered through trial and error, modern chemistry has fully explained. And that's what makes this reaction so fascinating. Something discovered centuries ago still feels like magic today. Let's really imagine what happens when gold meets aqua regia. You have a small piece of gold, solid, shiny, heavy, the metal you thought was untouchable. And then it touches the solution. At first, nothing seems to happen. You might even think, maybe this isn't strong enough. But then, slowly, something begins to change. The surface of the gold starts reacting. Tiny particles break away. Bit by bit, atom by atom, the gold begins to vanish. It's not melting, it's not breaking. It's dissolving, turning into ions and mixing into the liquid. The solid metal, the gold you could hold in your hand, literally disappears. And yet, it's still there. You just can't see it anymore. It's hidden in a completely different form. Now here's the crazy part. The process is reversible. The gold hasn't been destroyed. It's not gone forever. By using the right chemical process later, you can force the gold ions to gain electrons again. And slowly, gold begins to reappear. From invisible, back to solid. From liquid, back to the metal you know and trust. It's like watching something vanish and then come back from nothing. This is why chemists call it one of the most fascinating reactions in all of chemistry. Even the strongest, most stable metal on Earth can completely change its form, and yet it's still the same gold it always was. Let's talk about how this strange chemistry shows up in the real world and why it's something you must respect. In laboratories and industrial settings, aqua regia has important real uses. Chemists often use it to clean tough glassware, to remove stubborn metal residues, or to process small amounts of noble metals like gold, platinum, and palladium. But here's the catch. This mixture isn't just strong, it's dangerous. It gives off toxic gases, it corrodes almost anything it touches, and it can even explode if treated carelessly. Let me tell you about a real incident that happened in a chemistry lab. A student was using aqua regia to clean glassware and then put the leftover solution into a sealed waste bottle. The acid kept reacting and releasing gas. Pressure built up, and suddenly the bottle exploded. Acid sprayed everywhere. Thankfully, it was in a lab hood, so no one was seriously hurt, but this could easily have caused severe injuries. Another real case reported in forensic medicine was even more tragic. Someone drank aqua regia, and it caused fatal injuries because it's so corrosive to living tissue. These are not fictional stories. They are documented events that show how dangerous this stuff really is. That's why professionals always take strict precautions. Prepare aqua regia only in a fume hood. Never store it in a closed container. Dangerous gases will build up. Always wear proper protective gear. Goggles, gloves, face shields. And after use, neutralize it safely with water and a neutralizing chemical before disposal. So while the idea of dissolving gold sounds amazing, the reality is, this is powerful chemistry that can hurt you faster than it dissolves metal. Nothing about aqua regia is safe unless it's handled with absolute care and respect. And that's an important lesson in science. Not just knowing what can happen, but understanding why it's dangerous if misused.
What this entire process really teaches us is the power of chemistry. Gold, one of the most stable and valuable metals on Earth, can completely change its form. It can disappear and then reappear again. But the lesson goes deeper than just metals. It reminds us that every chemical has power, some of it amazing, some of it dangerous. And that power must be treated with respect. Aqua regia, as we've seen, can dissolve gold, but it can also seriously harm anyone who handles it carelessly. It can release toxic gases. It can corrode anything it touches. It can even explode if stored incorrectly. This isn't just theory, but real people have been hurt. So the big takeaway here is simple. Never perform dangerous chemical experiments alone. Always do it under the supervision of experts. Teachers or lab professionals, protect yourself, protect others around you. Even small mistakes can be life-threatening. The real magic of science is not just in what it can do, but in understanding it safely. So remember this lesson. Knowledge is powerful, but safety must always come first. And with that, we can truly appreciate the wonder of chemistry without putting anyone at risk.